we like to think, live, and operate in silos. Think of data scientists as the chef that is delivering a particular dish. I exist because the business has a need. The business doesn't exist because of me. When it comes to specific tools, it's the future. Don't try to fight it.
Hey everyone, welcome to the channel. My name is Abhinav and this is another episode of Masala Chai. If you have not checked out the previous videos, do check them out. All the links are in the description box below. We have had some super cool and really informative conversations with our friends. And today something very similar is going to happen because we have with us Agnel, as you can see on the screen, who is a long time analytics professional and practitioner, and we are going to learn about analytics career, education, and analytics space in general from Agnel. Agnel also has a really cool channel. It's called Thinking Aloud with Agnel. Agnel brings a lot of industry leaders, I would say, who talk about the society, technology. I think you recently did an episode on Roblox, which is a startup that just went public with an 11-year-old kid. Check it out. The link is in the description box below. It's called Thinking Aloud with Agnel. Also, I know there are a lot of things, Agnel, I'm sorry. But you are such an amazing person. I have to keep adding one after the other. Agnel has recently also co-authored a book.
So it's right here. I don't know if you folks can see this. It's healthcare informatics strategies for the digital era. So quick thing on this is it's the actual author of the book is my mentor and my former professor. His name is Stefan Kudiba. You can probably see it here. I have written a chapter in this book on patient data analytics and all of that space because I've kind of worked in that space and I have a passion for that space. So if any of you are in healthcare, in the pharma space or any of those related spaces, right, you will probably really love this book. But you can go to the publisher's website, which is Taylor Francis, right here. It's also available on Amazon.
Agnel, welcome to Masala Chai. I hope you already have your cup.
Just to let you know, so this is the first time I made masala chai in about a year and a half maybe.
Just for this?
Just for your show. Yeah, I'm generally a coffee guy.
Thank you so much. I feel honored hearing that.
So firstly, thank you. I think, it's great that we're talking. I'm in the analytics space. I think I've been in this space for 10 or 11 years now. How did I get here? Partly because of the jobs that I've held, and partly also because when I was doing my master's, Abhinav, I kind of took what I would call a minors in data science. I was just fascinated by what it could do, right? So I think all of us kind of think in a way that's partly data driven, but when I got that real formal education and teaching in that space, I was just like fascinated. I was like, this is great, right? And the reason I say that is because my undergrad was in telecommunications engineering. So I used to be very technical. I'm an engineer by trade. I don't know, not by trade, but at least by an undergrad education. But
everyone of us is an engineer in some or the other way, I believe, right?
Right. That's so true. That's so true. Yes. I was in, product management and consulting and stuff like that. I was a business analyst for a few years. Then I, moved out of consulting into the industry. So today I work for a manufacturing firm and, it's a Fortune 50 manufacturing firm, and I'm a senior manager of analytics. So I kind of help deliver analytics for what I would think is between a $7 to $10 billion sub-business of the large firm.
Nice.
So that's what I do. So I did my master's in NJIT.
Okay.
I did not do analytics as my master's. So what I did was business and information systems. They gave us a lot of options to, pick electives and almost like a minors, right? So I could like pick 2 or 3 different courses that was in a particular area. And then I picked what was called at that time data mining, right? So that was kind of an elective or a path that we could pick. So I picked data mining, and that's when, my respect for the field grew even more.
And I do not know if you have already gotten this multiple times, but I just cannot resist asking, are you related to Ileana D. Cruz at all?
No, unfortunately, no. I wish I was. And if she is watching this, please, please be known that I'm a big fan as well. So, yeah.
You made a really big wish about Ileana D. Cruz watching this channel. If you're watching, please subscribe. Let's chat a little bit about analytics. How would you define analytics for someone who doesn't know it at all? Let's say I'm a school kid who's just getting out of school and trying to decide my career. What would you tell them about analytics?
This is the tricky thing about analytics, right, Abhinav, is that if you talk to five different people, they'll give you five different definitions of analytics, right? I mean, or if you talk to 10 different people, you'll probably have 12 different definitions, right? So let me just make that, the sixth different definition, but I'm going to try and simplify it. In my opinion, in my perspective, it's basically the art and science of using data, right, to help businesses make the right decisions.
There has been a boom in recent times, right? Everyone has been talking about analytics and data science and all that stuff. You also mentioned data mining. Would you say that it's very much concentrated in more engineering oriented domains, or it could be applied anywhere?
Analytics can be used anywhere, right? So you could use it in sales, you could use it in marketing, you could use it in engineering, you could use it you name it. And if you're collecting data, if you're collecting any kind of data, you can actually use analytics on top of it. Maybe the perception as to why there's a lot of, why analytics is kind of, I think, highly correlated with engineering is probably because there are a lot of terms that are used in the analytics space that are probably engineering related, like data engineering, like data science, and stuff like that. They sound like very technical terms. So you think that, oh, this may be just, engineering and very technical, but the application of analytics, right? Now, it's not a question of who does it, but the application of analytics. So applying analytics, you could use it to anywhere where there's data collected. If there's a point of sale system, you want to run analytics on it to look at trends or patterns, you could do that. There is no engineering there, right? I mean, it's not an engineering field, it's sales, right? You're running marketing campaigns and you want to see what is the effectiveness of that campaign. There are analytics methodologies that help you deliver, give you an answer for it.
Anywhere you are trying to either optimize something using data or even just basic tracking, monitoring, even that you would consider to be analytics. So what my mom does at home when she's tracking the budget, using all the bills and everything that she's getting from the Kirana shop, would you say like even that is analytics in the back end?
In a way, yes. Okay. In a way, what she's probably doing is also analytics, because she is kind of optimizing. She's kind of optimizing the spend of your family, right? She's ensuring that, okay, she's got a budget. I can spend this on this. How much have I spent so far? What is remaining? Technically, there is a lot of analytics that's happening behind it. It's just that we don't know.
And you mentioned very briefly about data engineering and data science. I'm interested in learning, how would you differentiate these fields now? Let's talk about data engineering to start with. What would you say is data engineering versus analytics, if there is a precedence, like one comes before another? And then the same question for data science as well with respect to analytics in comparison to analytics.
If you talk to five different people, you'll get five different perspectives on this. Data scientists generally are more, I would think, business facing, right? And what they do is also slightly different in the sense that they are more stats heavy. They are probably computer science engineers, and they solve the final business problem. What data engineers do is they enable the data scientists, right? So they enable data scientists by giving them the right data in the right form. The best analogy that I have for this, and I kind of, when I talk to people, is think of data scientists as the chef that is delivering a particular dish, right? Whereas your data engineers are the other people in the kitchen that are making that dish happen, right? So they're ensuring that all the different vegetables are cut in the right way, right? The chef has everything that is needed to make that particular dish, because the chef cannot ensure that the onions are cut, the tomatoes are cut, the vegetables are cut, right? So the data engineers ensure all of that is in place so that the chef can do his or her job, right?
That was a mouth-watering explanation. All in all, data engineering is setting up the infrastructure for data scientists to be successful. Where does an analyst fit in this scenario?
technically everywhere.
Okay.
To be honest, Abhinav. So an analyst could be data engine, and this is where I think this is where different companies are different, and sometimes different teams within different companies are different, right? So an analyst could be someone who is, so if you look at it in terms of think of it as a supply chain, right? So an analyst could be someone who's sitting after the data engineer to ensure that the data is fine, and maybe providing reports to the business, right? So that could be an analyst. An analyst could be someone who's working with the data engineer to help with data accuracy, right? Because an analyst is, let's say, more business facing and kind of understands that, yes, this particular month we did $13 million of sales. So when my data engineer is building my, let us say, data mart or my data lake, right, I should see approximately 13 million dollars of sales, or 12.9 or 13.1. But so I work, so if I'm the analyst that is working with the data engineer, then I do something else. So ideally, analysts can sit everywhere. Now, on the other end of the spectrum, analysts can also sit after your data scientist, right? If you think of, let's say, there's a system, there's an ETL, then there's data engineering, there's data science, but then analysts can also sit after that to see, my data scientist has predicted that we are going to see $15 million of sales this month, but how are we tracking against that, right? Or how am I reporting to show, the data engineer says, the data scientist says 15 divided by 4 this every week, and I can kind of report against it, right?
Okay.
So analysts can sit anywhere in the supply chain, is what or the value chains rather.
Are the skills transferable though? So if I'm an analyst, do you feel like I can be a data engineer or I can be a data scientist?
Absolutely are transferable, in my opinion, Abhinav. I think what is not transferable is your attitude.
Okay.
Right. So if you have the attitude of a problem solver, you can actually do anything. But if you have the attitude of, let's say, of an order taker, then maybe one is better than the other for you, right? So I don't want to pigeonhole people into different roles, but I would say skills are transferable, attitude is probably not. So
what would you say are the different types of analytics?
I'll probably go back to Gartner for this, Abhinav, right? So Gartner kind of defines this very, very well. So let's say I have a graph here. On my y-axis is my value, and so the amount of value that I get. On my x-axis is basically the amount of effort that's needed, right? And they've kind of overgeneralized this, but it's still very interesting. So they've kind of divided it into 4 parts, right? So there's descriptive analytics right at the bottom here, which is basically low value but also low effort. Then after that, there's diagnostic analytics. So descriptive, diagnostic, predictive, prescriptive. Descriptive is almost just telling me what happened. It's like telling me I walk into a doctor's office, I have a temperature of 101, right? That's it, right? It's telling me the speed of my car, right? Diagnostic, in my opinion, tells me the why behind the what. Diagnostic is one level deeper, in the sense that I have a temperature of 101 because I have an infection, or I did $50 million of sales, whereas I was expecting $30 million.
Why?
Because the why behind it. Predictive is more of what will happen. I think the most common example of this is weather predictions, right? So become very, very accurate now, right? It's just amazing how accurate all these systems are. Prescriptive is what can I do to make something happen. All of us have experienced prescriptive analytics, we just don't know. And I think the most common example of prescriptive analytics is your flight prices, right? When you're looking to book a flight, different times, they cost different, right? Even on the same day, if you book a flight at different, hours in the same day, they actually cost different, right? So what that is telling me is, it's telling, let's say, United Airlines, that United Airlines, if you want to maximize your passengers, here's how much you must price. If you want to maximize your profits, here's how much you must price. If you want to maximize your sales, here's how much you must price. It's basically telling me what to do based on a goal that I have.
When you said these 4 categories, descriptive, diagnostic,
predictive,
and then prescriptive. do they hold equal importance in a company, in an organization, or would you say that prescriptive is like way fancier than descriptive, and like I should not focus on descriptive at all?
Think of each of these, right? So think of descriptive as your foundation. Without a good foundation, you will not be able to build a good house or a good commercial building. Everything, in my opinion, starts with descriptive. When you do something that's descriptive, you start to see things and you ask for the why behind it, right? So that's when you go to
Diagnostic.
diagnostic, right? And then once you see the why, you want to do the other two. You do bring up a very good point here, in the sense that there is more value in doing prescriptive and things like that, right? So I mean, prescriptive is probably the most value, and predictive is also very high value. But without the right foundation towards it, you will not know what to do. While it's very cool, it's very sexy to kind of do predictive and prescriptive, right? Yes, it is very cool, it is very important, but it is like saying that I will not do the basics, and I just want to get to 12th grade, but I will not do grades 1 to 10, right? So that in my opinion would be stupid, right? There are conversations that I have on this, Abhinav, is they say, but we want to get to there fast. Yes, you can get there fast, but you cannot avoid the first two. It's just that you can circle through those iterations faster.
We talked about analytics. We talked about the types of analytics. We touched upon data engineering, data science a little bit. Everything is looking super good so far. What are some of the misconceptions you would say there are around data analytics? What are some of the mistakes that have been made or that can be made?
I've made a lot of mistakes myself. But first thing, right, Abhinav, is that analytics or data science or machine learning or AI or whatever you want to call it, right? Give it a cool name or give it a boring name, but it's not magic, right? It's not, you cannot just use the term and say, okay, here's 10 data scientists, here's 20 data engineers, here's a bunch of ETL folks, here are the world's coolest tools, and now make magic out of it. It's not going to be possible that way, right? So I think senior leaders have to understand that, companies have to understand that is not magic. And the way you want to think about analytics is, so there are two ways you can think about analytics, right? Is that what I would call a top-down approach, right? You have a business problem, and then you try to figure out what methodologies and what data can be used towards it, right? To solve this business problem. But you are starting with the problem first, and you try to solve that. You try to solve the problem, right? Or answer a question. The other way I think of analytics is that it's bottom up. You have, a lot of data, you don't know what to do, so you try to do different things, right? Now, in my opinion, about 80% of the time should be spent top down, right? Pick business problems that will build value for the company, right? And then start to solve, start to say, okay, what methodologies, what data can we use? Adding real value to an organization. Why I say 80% is because 20% of the time, data scientists, data engineers, analysts, they're very smart people. They see trends in the data, right? So you have to create this reverse loop where people at this layer can say, hey, we've found these things which you probably may not have thought about, right? Can you think about it in terms of a business problem? We should do both things, but we should do majority top down, but we should also have very clear things going up as well. There are a couple of other mistakes as well, right? And I think, one last one probably that I'll talk about is, so when you're working on data science projects, it's very experimental, right? So you have a hypothesis, it may work out, it may not work out. So it's also important for, the business side of it, senior leaders, to kind of understand the process. They have to be what I call data literate, right? They need not have PhDs in statistics. That's not what is expected, but be data literate to kind of understand, okay, so this is possible, this is not possible, here's the why behind it. Now, on the data science side of the world is, as you're doing what is called exploratory data analysis, you're going to see a lot of different things, right? But make a note of it, move on, focus on the business problem. So sometimes we see something extremely cool, right? And then we're like, oh my God, let's just look at this, and we forget the business problems. So one thing I always tell my teams, Abhinav, is we are in the data place, in the data domain or whatever you would want to call it, right? And the business doesn't exist because of us, right? We exist because the business has a need. So don't throw your attitude around unnecessarily. And that's to myself as well. I don't throw my attitude around unnecessarily, right? I exist because the business has a need. The business doesn't exist because of me. The business probably can survive without us, right? May not be as efficiently, probably get eaten out by other people. The other probably mistake, right, and that I can talk about. Analytics needs to stop being order takers and be business partners, right? Be consultative and stop being order takers. So this whole thing of give me requirements and then I will do it, and tell me what SQL code is it, a left join or a right join. I mean, business people don't know whether it's going to be a left join or a right join, right? And that's where your common sense is needed, right? So develop that business acumen as well.
We talked about mistakes. So obviously, these are some really good tips for someone who doesn't want to commit mistakes while they are pursuing a career in analytics. What would you say are some of the tips for someone who wants to be successful in the analytics space?
Definitely business context. Don't only look at the what needs to be done, also look at the why are we doing this. If you genuinely understand the why behind you doing something, maybe the consultant in you can come out and probably give a better idea. Ask for the why behind why are we doing something like this, right? It's partly an art and partly a science, right? And think of the art behind it as well, right? Because the science over time is going to be so common that it's going to get automated, right? So if you're only going to think about the science behind it, you will lose your job to automation. We like to think, live, and operate in silos. I'm a data scientist. I will only do what a data scientist does. I'm a data engineer. I will only do what a data engineer does. I'm an analyst. That's a data scientist job. I'm not even going to talk to him or her. It's too much of silos, right? So it's very important for you to be focused on your job. It's very important for you to do your job. What is the data scientist doing? What is data engineer doing? What is the ETL person doing? What is the analyst doing? What is the business needing, right? Because when you understand what they're doing, you don't have to do what they do. But if you can understand what they do, you could probably come up with better ideas on how something could be done. Or maybe you could do your job better, right? You could design a better, you could design a better algorithm, right? Or you could give them extra fields that you see in the data set, right? So there's so many different things that you could do. So don't be a silo buster. Be a silo buster. Don't be, the silo king, right? So think like a doctor, right? A doctor's job is not to prescribe a medicine to you, right? So writing a prescription is not the doctor's job. The doctor's job is to ensure that you're well, right? So the same way, whatever your role is, your role, of course, is that of a data scientist and do it well. But your role is to ensure that the company is successful, the project is successful. So always think bigger picture. So it's project success and company success, not am I doing data engineering as asked. Right?
So the first one was get some more business context. Second one was be a silo buster, which is a really good one. And the third one was think about the bigger picture. Do not just think about your core role. Before someone gets or becomes successful, how do they even get into analytics? Is it only about getting a formal degree, or they can always go through some of the open online courses or things like YouTube?
The road to analytics success, there are multiple paths to it, right? If your destination is that, it's very subjective. It's very case to case. But let's say I'm working for a company and I am in, some completely different field. Right? Let's say supply chain. I'm a supply chain person, right? Now, if I have an interest in analytics, I could do a few things. One is definitely, if there's a way that I can get, Udemy, Coursera, and things like that, get a formal degree. But a formal degree will only take you, a certain amount of the way, right? A certain way there. It will not do everything. I would probably recommend to people, especially if they're in a particular company and, they have an interest, is reach out to your bosses, reach out to your managers, reach out to people in analytics teams and say, hey, I have an interest. Can I volunteer on a project?
When we talk about data visualization and tools that are available, something like Tableau, which also can do these things for you. So these are off the shelf tools that are available to you. You just input all the data. You do not have to write any formulas or code. What's your view on such off the shelf tools that are available, which already have the programs and algorithms, or the code to run a regression for you, or to find that sweet spot, which is the answer to your business problem? Should I learn Tableau or should I learn coding in R and Python?
When it comes to specific tools, it's the future. Don't try to fight it, right? So that's where it goes to the art and the science part of it. The science over time will get automated, so you have to learn the art as well, right? So the art is, what is the right model to run? What are my list of driver variables? What am I looking to predict? What is the right data set? Basically the art is asking the right questions, because the science of it eventually will be automated. So you can pick, I don't know, Tableau, or I was looking at this other tool, I'm forgetting the name now, right? You just throw the data set in, it'll tell you different models to run. On the other side, you asked, is it important for me to learn coding, and, as against picking up Tableau and stuff like that? If you have the time, if you have the opportunity, do both. If you have the time for only one, I would say, unfortunately, pick up the coding part of it, because sometimes it's more important for you to understand the basics.
I was expecting a different answer, but
eventually it's understanding the art of it is way more important than understanding the science behind it. So
when we talk about data visualization, how important do you think is that aspect in the analytics world? Because crunching numbers is definitely the more valuable part, but presenting it on, let's say, a dashboard or in a deck that's meant for the business, it's the second part of it. Fortunately, unfortunately, that's the more critical one, because that's how the decision will be made, right?
A picture is worth 1,000 words. Data visualization is the analytics equivalent of that. One visualization is worth 1,000 lines of code.
Okay, thank you for saying that. Now I think you redeemed yourself.
We are here to help the business succeed, right? And if you think about it, business users, if you talk to them, if you give them, let us say, an Excel file with 10,000 rows, right? And then say, here's the pattern in it, or go figure out the pattern. Instead of that, if I give them, let's say, one bar chart that tells me sales trend by month, and then tells me, okay, give them a pie chart that tells me, here's how your regions are divided. It makes a lot more sense to them, and they can understand that in 10 seconds, as against spending 10 hours on that Excel file with 10,000 rows, right?
Should an analyst also focus on that aspect though? I know I have the numbers, I know what my average sales in all the countries across the world are. Now I present it as a simple table in an Excel sheet, versus I show a map of the world with bubbles that are sized by the averages.
It is worth it.
Okay.
My personal opinion. There will be people who disagree, but my personal opinion, it is worth it. Now, if you've used Tableau, right? If you can spend, let us say, 5 to 10 minutes to create that world map, all you have to do is right click and say duplicate as cross tab. It gives you the cross tab. You can put both of them together in a dashboard. You have the solution right there. So if you get one, the second one is not that difficult. But if you can spend 10 minutes to convert that picture's worth 1,000 words, right? If you can spend 5 to 10 minutes to do that, there is exponential value.
A lot of discussion around analytics as it is today. What is Agnel's view on the future of analytics?
With AI and machine learning and all of that, a lot of descriptive and diagnostic will probably be automated. It's not that it will not be important. It will still remain extremely important. It will still be the foundation, the building blocks of what we have to do as any organization must do. Parts of predictive and prescriptive will also be automated. A lot of effort and a lot of skill will be needed in that space. Artists that know what model to use, what data to use, and what to predict or what to prescribe, that will be the skill of the future, in my opinion, as against the ability to write good SQL code. I can actually type like how I would do a Google search, and Tableau will draw a good pie chart or a good bar chart for me. So that skill over time will only get better, just like a Tesla self-driving car, right? It'll only get better, right? So for us, we have to know where to tell the car to go, to the right place. The car will do most of it. One of the biggest shortages is going to be what is called translators, right? Because what happens is there's business speak, there's data speak. These two people don't understand each other, right? And the business speak will always be there. The data speak, to a large extent, will get automated. It's the people in the middle that kind of understand both, that, the artists in the middle, the empathizers in the middle, the translators in the middle, right? It's that skill set that I think will grow.
Thank you so much, Agnel. This has been extremely valuable, and I hope whoever is watching this, whether they are a student, they are a professional, they are not in the analytics space, this is going to be very valuable for anyone who watches, loaded with information, a lot of really cool insights from someone who has been in this space for 11 years. And I'm definitely looking forward to all the guests that you are bringing on your channel, Thinking Aloud with Agnel, because some of those conversations are super interesting.
The goal of my channel, Abhinav, is to be at least half as interesting as your channel is. I find my channel extremely boring.
This is the end of the episode Talking Analytics with Agnel. If you like this video for any reason, make sure you hit the like button and that you have also subscribed to the channel. Comment down below what you think about this episode. Agnel's LinkedIn profile is also linked in the description box.
I think Twitter might be better, but yeah, LinkedIn's also fine.
Reach out to him on Twitter. The link is again in the description box below. Thank you so much, Agnel, for taking out the time and talking about analytics.